Hello PreCalc. This is getting put up online a little later than normal. It's almost 5 o'clock, so it should be up by 5:30. So I apologize if you checked for it earlier, especially since you got to go home early today. Alright, so all I'm doing tonight, as you can probably tell, I have finished all the topics for this particular section. So we're looking at preparing for a sequence and series test. So what I've noticed is when you were doing a certain little section in the daily work, you were very good at it. My question is, do you remember back how you did it? So we're going to try to pull it all together, and I'll give you a review exercise in class tomorrow. So here are the things I'd like you to jot down in your comp book that you need to know to do well on the sequence series evaluation. All right, so we're going to look at arithmetic sequences. So given the first term, let me see if I can just pan out a little. Whoops. Given the first term and the common difference, can you write the first 5 terms? So on video here, I might be going faster than you can write, so use the pause button as needed. Find the indicated term for an arithmetic sequence. So I'll give you some information and ask you, what's the 21st term in this arithmetic sequence? So you will have to pull out one of your formulas. It's going to be a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference. And there's only about 5 formulas, and I will ask you to memorize them for extra credit. If you do not want that extra credit, I will give those to you on the test day. Oops, I already wrote it. So there's double reinforcement there. All right. Another thing you might be asked to do is write an algebraic expression that generates a sequence. That's the one where we were looking at, say, a sequence, not necessarily arithmetic or geometric, but it might be. And suppose we, sorry, I make you seasick. Suppose we have 2, 5, 10, 17, one like that. So you have to think, what did we do to 1 to get 2? What did we do to 2 to get 5? What did we do to 3 to get 10? 4 to get 17. So you might notice, what's the difference between them? Well, this was 3, but this was 5, so it's not arithmetic. This times this, something times this is not going to work. So is there another relationship? So you can look at squares. What's this squared? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Do you see it? So it's going to be n squared plus 1 will generate all of those terms. So you might have to find the algebraic generator of a given sequence like that. Find the next term in a sequence. So I could give you something maybe like this and say what would come next. Would you say 26? All right. Oh, there's the phone. I'll be right back. That's fine. Very good. Thank you. Sorry to ditch you like that, but we're still without hot water. And they won't come when you have an appointment. This is like the 3rd different one who's come if you don't answer the phone when they're on your way. So I had to dive for the phone, so sorry. Okay. Find the next term in a sequence. use recursive formulas. So recursive formulas tell you how to get the next term in terms of the previous terms. For example, if the first term is 2 and the second term is 5, and this is the relationship recursively, this tells you a term is going to be found by adding the term previous and the term previous. If that makes sense. I have a hard time explaining that, do I not? So, in other words, suppose we say k is 1. So then we're looking for a sub 3. And here k becomes a sub 2. And here, when we put k as 1, we get a sub 1. So we can get the third term by adding the second term and the first term. So we're going to get 2. So the sequence is going to go 2, 5, then we're going to get 7. So we added 2 and 5. We added term 1 and term 2. Alright, so then it's going to reoccur. That's why it's recursive. So we get 12, and then we're going to add those two and get 19. So hopefully you remember we did a section or so of those. We were introduced to the factorial notation, and we were able to simplify factorials like, I don't know, something like that, simplify that. Sometimes factorials show up in our work. Find the sum using summation notation. So you have to understand what that means and how to use it. Find the partial sum. So suppose we have an infinite summation indicated by this expression, but I want the fifth partial sum. That means I'm going to add the first 5 members of this sequence. So you should recall how that was done. And then we learned how to find the sum of an infinite series. Sometimes it was not possible. R had to be between, the common ratio R had to be between -1 and 1. And then we used the formula a sub 1 over 1 minus R. We had to identify a geometric sequence. Look at a sequence. Is it geometric? I could ask, is it arithmetic as well? Given the first term and the common ratio, can you find the first 5 terms? So indicating what it has a common ratio means we are in geometric land. Alright, and the last two I said is find the nth term of a geometric sequence. And the nth term was a sub n equals a sub 1 r to the n minus 1. And lastly, change a repeating decimal to a common fraction. Alright, all of those topics will be repeated on a review or on the test, and those that are closely associated to these skills. Alright. I hope that you will be gearing up for a good test result. First one in quarter 4. So we want to finish strong. Alright, that's all for tonight, and see you tomorrow when we practice our review. Okay, till then, carry on class, carry on.